Simple question. Why can't anything go faster than light? You've heard it your whole life. Speed limit of the universe. Nothing can break it. But why? Most people never ask. But if you do, something changes. Because the answer isn't just physics. It's about what reality actually is. And once you see it, you can't unsee it. We think of speed as something you can always add to. You're on a train moving 50 miles per hour. You walk forward at 3 miles per hour. Now you're moving at 53. Simple. You throw a ball from that train. The ball inherits your speed, then adds its own. Right? That's how motion works. That's how everything should work. Right? Wrong. Because light doesn't play by those rules. And here's the strange part. Light always moves at the same speed. No matter who's watching, no matter how fast you're going. You shine a flashlight while standing still. The light moves at about 186,000 miles per second. Now you get on a rocket going half the speed of light. You shine that same flashlight forward. Common sense says the light should now be going faster. Your speed plus light speed. But it doesn't. The light still moves at 186,000 miles per second. Exactly the same. Not a fraction faster. This isn't theory. This is measured reality. Every experiment we've ever done confirms it. And when Albert Einstein sat with this fact in 1905, he didn't dismiss it. He followed it. He asked a question nobody else dared to ask. What if light speed isn't just a speed? What if it's the speed? What if it's the structure of space-time itself? Now think about what that implies. If light always moves at the same speed, no matter what, then something else has to give. And that something is time and space. They bend, they stretch, they slow down to keep light's speed constant. Because this connects to the stars, and to you, and to the fabric of everything. Imagine you're on that rocket again, moving close to the speed of light. You look at your watch. 1 second passes, but to someone standing still on Earth, watching you fly by, your second takes longer. Your clock runs slow. Not because it's broken, but because time itself is moving slower for you. The faster you go, the slower your time becomes. This isn't a trick. It's called time dilation, and it's real. We've tested it with atomic clocks on airplanes, with particles in accelerators, with GPS satellites orbiting Earth. Every single time, the math holds. Time is not absolute. It's flexible. It bends around speed. And here's the strange part. Space bends too. On that same rocket, moving near light speed, distances shrink. The space between you and your destination compresses. A light year might become half a light year. From your perspective, not because you're imagining it, but because space itself is contracting in the direction you're moving. This is called length contraction. Another prediction of Einstein. Another confirmed reality. The ruler of the universe is elastic. It stretches and contracts depending on how fast you're moving through it. And nobody noticed this for thousands of years. Because we move so slowly. Our trains, our planes, our rockets, all of them are crawling compared to light. The effects are tiny, unmeasurable in daily life, but they're there, always. So now ask yourself this. What happens if you try to reach light speed? You push harder. You add more energy. You accelerate. But something bizarre happens. The faster you go, the heavier you become. Not heavier like you ate too much. Heavier in mass. Your actual mass increases. Because energy and mass are connected. Einstein showed us that with the most famous equation ever written, E equals mc squared. Energy is mass. Mass is energy. They're the same thing in different forms. Two sides of the same cosmic coin. So when you pump energy into a rocket to make it go faster, some of that energy turns into mass. The rocket gets heavier. And the heavier it gets, the harder it is to accelerate. You push more. It gains more mass. You push even harder. More mass. It's a loop. An impossible loop. A cosmic trap. To reach the speed of light, you'd need infinite energy. And infinite energy doesn't exist. Not in this universe. Not anywhere we can reach. But it goes deeper than that. Because light itself has no mass. Photons, the particles of light, are massless. That's why they can move at light speed. They don't have to fight their own weight. They don't carry the burden of inertia. They just go. at the only speed they can go, the speed of causality, the speed at which cause and effect propagate through space-time. And that's where it becomes unforgettable, because the speed of light isn't really about light. It's about information. It's about how fast one part of the universe can affect another part, how quickly a message can travel from here to there. Gravity moves at light speed. If the sun suddenly vanished, we wouldn't feel it for 8 minutes, because the gravitational wave telling us the sun is gone travels at light speed. Same with light itself. We see the sun as it was 8 minutes ago, not as it is now. We live in the past of everything we observe. The stars you see at night, some of them are already dead. Their light is still traveling, still reaching your eyes, long after they exploded. Ancient photons carrying ancient messages, crossing the void for millions of years, just to land on your retina on a Tuesday night while you're taking out the trash. Now think about what that implies. You're not just looking at the stars. You're looking back in time. The farther you look, the deeper into the past you see. The most distant galaxies we photographed, we're seeing them as they were 13 billion years ago, barely a moment after the Big Bang, when the universe was young and hot and dense, when the first stars were just beginning to ignite. The universe is a time machine, and the speed of light is the key. It sets the pace of history. It determines what we can see, what we can know, what we can ever hope to touch. So why can't we break it? Why can't we just build a better engine, a more powerful rocket? Because breaking the speed of light would mean breaking causality. It would mean effects happening before causes, messages arriving before they were sent. You could receive an answer before you asked the question. You could attend your own funeral. You could shake hands with yourself as a child. And that doesn't just violate physics. It violates logic. It violates the structure of reality as we know it. The universe would become incoherent. Paradoxes would multiply. Cause and effect would unravel. And reality, as far as we understand it, depends on causality, on the arrow of time, on past leading to present leading to future. In that order, always. Carl Sagan understood this better than most. He didn't see the speed of light as a frustrating barrier. He saw it as a profound truth, a reminder that we live in a universe with rules, deep rules, beautiful rules, rules written into the fabric of existence. And those rules connect us to everything. Because here's the thing. You are made of atoms, carbon, oxygen, nitrogen, iron in your blood, calcium in your bones, phosphorus in your DNA. Every single one of those atoms was forged inside a star that lived billions of years ago, a star that burned for millions of years, fusing hydrogen into helium, helium into carbon, carbon into oxygen, building the periodic table one element at a time. In its core, under unimaginable pressure, at temperatures that would vaporize worlds. And then that star died. It ran out of fuel. Its core collapsed. And it exploded. A supernova, brighter than a billion suns, visible across the galaxy. And in that explosion, it created the heaviest elements: gold, silver, uranium, elements that can only form in the violence of stellar death. And it sent all those atoms flying through space, at incredible speeds. Not quite light speed, but fast. Fast enough to cross light years. Fast enough to spread across the galaxy, until they drifted into a cloud of gas and dust. And that cloud collapsed under its own gravity, and formed our sun, and the planets, and Earth. And you. You are made of stardust. That's not poetry. That's physics. That's chemistry. That's the literal truth. Every atom in your body except hydrogen was made in a star, or in the collision of dead stars. Neutron stars smashing together, creating tidal waves of gold and platinum, scattering treasure across the cosmos. And some of that treasure ended up in you, in your wedding ring, in your smartphone, in your bones. And the light from those ancient stars, some of it is still traveling, still moving, still obeying the same speed limit that governs everything, the same limit that keeps reality coherent, the same limit that prevents paradoxes, the same limit that makes the universe understandable. And here's the strange part. The speed of light also governs what we can ever know. There are galaxies so far away that their light will never reach us, because the universe is expanding, and in some directions, space itself is expanding faster than light can cross it. Not because anything is moving faster than light through space, but because space itself is growing, stretching, creating new distance between galaxies. Faster than light can cross that distance. Those galaxies are beyond our cosmic horizon, forever. We will never see them, never know them, never touch them. They exist, but they are unreachable. Not because we lack the technology, not because we lack the ambition, but because the universe has a structure, and that structure has limits. Fundamental limits, written into the laws of physics. Does that make you feel small? It should, because you are small. Cosmically speaking, a collection of atoms, on a rock, circling a star, in a galaxy of hundreds of billions of stars, in a universe of hundreds of billions of galaxies, most of which you will never see. But it should also make you feel something else. Wonder, because you are a part of this, a conscious part. You are the universe looking at itself, trying to understand itself, asking questions, building telescopes, writing equations, measuring the speed of light. And every time you ask why, you're participating in something ancient, something cosmic, something that started with the first humans who looked up and wondered. When you were a child, you probably looked up at the stars and felt something. Maybe you didn't have words for it, but it was there. A sense of mystery, a sense of connection, a longing, a sense that the universe was bigger than your bedroom, your house, your street, your town, bigger than anything you could touch. And you were right. It is bigger, vastly bigger, incomprehensibly bigger. But the rules that govern the stars also govern you. The same forces, the same particles, the same speed limits. The photons bouncing off the screen into your eyes right now. They're moving at the same speed as the photons leaving a star 1,000 light years away. Same rules, same universe. And that's the beautiful injustice of it. We are stuck here, on this pale blue dot, circling an ordinary star, in an ordinary galaxy, in an ordinary region of space. We cannot travel faster than light. We cannot explore most of the universe in a human lifetime. We are bound by the same laws that bind everything else. Rocks, rivers, planets, stars. But we can understand. We can measure. We can think our way across the cosmos. We can look at a distant star and know what it's made of. We can decode the light, break it into a spectrum, read its fingerprints, see the elements, hydrogen, helium, iron, the same elements in us. We can measure how fast it's moving, how old it is, when it will die. And in doing so, we touch the infinite. We transcend our limitations, not physically, but intellectually, spiritually. The speed of light is not a prison. It's a framework, a structure, a reminder that reality is not arbitrary, that there are reasons, deep reasons, and those reasons are discoverable. Einstein discovered one, sitting in a patent office in Switzerland, thinking about trains and clocks and light. No lab, no telescope, no supercomputer. Just thought, just curiosity, just the refusal to accept that's just how it is. He asked why, and the universe answered. And here's the final strange part. The speed of light connects everything. Your heartbeat, the rhythm of your breath, the chemical reactions in your cells, the electrons flowing through your nerves, the sun warming your face, the stars you see at night, the cosmic microwave background, the afterglow of the Big Bang. It's all woven together by the same thread, the thread of causality, of cause and effect, of past leading to present leading to future, at exactly 186,282 miles per second. Not a mile faster, not a mile slower. So the next time someone tells you nothing can go faster than light, don't just nod. Stop, think, ask why. Because the answer is not a wall. It's a window into the deepest structure of reality. A structure so elegant, so precise, that it allows stars to shine, and atoms to dance, and time to flow, and you to exist, and to wonder, and to ask questions. The universe is under no obligation to make sense to us, but it often does. And when it does, it's breathtaking. Light speed is the limit, not because the universe is cruel, but because the universe is coherent, because reality has rules, and those rules are beautiful, and once you see it, you can't unsee it. I'll leave you with that. If this made you think, hit like, and comment below. What part surprised you the most? Subscribe for more videos like this. See you next time.